Hi, I'm Viveka and welcome to Tech Rise with Viveka. I simplify complex technology concepts into practical and easy to understand explanations, especially around generative AI, LLMs, AI agents, RAG, MCP, and modern technology. In today's video, we are going to understand one of the most fundamental concepts behind LLMs, tokens. You may have heard terms like token, token ID, token limit, context window, or token usage. But what exactly is a token? And why does an AI engineer need to understand it? Let's break it down in the simplest possible way.
Have you ever wondered what exactly happens when you type a question into ChatGPT or Claude or any other LLM? You see a sentence, but the model doesn't process your sentence exactly. You and I read it. Before the LLM can work with your text, that text is broken down into smaller pieces called tokens. And if you're learning generative AI LLMs or AI agents, understanding tokens is one of the first concepts you need to get clear. Why should you care about tokens? Because tokens are connected to almost everything you do with an LLM. Context windows, prompts, RAG, memory tools, and even cost of running an AI application, MCP, are all connected to token usage. So let's start with the simplest question. What exactly is a token? Think of a token like a building block. Imagine Lego. You don't build an entire structure using one giant Lego piece. You combine smaller pieces to create the final structure. Language can be thought of in a similar way. A sentence is a complete structure, and tokens are smaller pieces that the LLM works with. But here is the important part. A token does not necessarily mean one complete word. A token can be a complete word, it can be a part of a word, it can represent punctuation, and depending on the tokenizer, it can also include space related information. So, the simplest rule to remember is token does not equal to word. Let's take a simple example. Suppose I write learning AI is exciting. As humans, we naturally see individual words, but a tokenizer doesn't simply count the words. It looks at the text and breaks it into pieces according to its vocabulary and tokenization rules. A common word may be represented as one token, while other word may be split into smaller pieces. A punctuation can also be represented. Now, you might ask, why don't we simply create one token for every word? Because language is huge. We have different languages, technical terms, programming code, names, URLs, emojis, and constantly changing vocabulary. Creating one token for every possible word would make an enormous vocabulary. Instead, tokenizers use reusable pieces of text, and this is where BPE comes. One commonly used approach is called BPE or byte pair encoding. Don't worry about the complicated name. The basic idea is quite simple. Imagine the tokenizer sees words like play, playing, played, player. It can recognize the certain patterns occur repeatedly. So conceptually, we can think of these as play plus in, play plus it, play plus er. The exact tokenization depends on the tokenizer, but the key idea is that reusable pieces can be combined to represent different words. Now imagine I create a word techify AI. Maybe that exact word doesn't exist as one of the token in the tokenizer's vocabulary. Does that mean the model can't process it? No. The tokenizer can potentially break it down into smaller pieces that it already knows. The exact split will depend on the tokenizer, but this is the important idea. Unfamiliar words can be represented into smaller usable pieces. And tokenizers aren't limited to words. Look at this sentence. Hello world. We have words, but we also have punctuation. The comma and exclamation mark are part of the text too. And depending on the tokenizer, spaces can also be incorporated into token representation. So when you open a tokenizer and see something that doesn't look exactly a normal word, don't be surprised. A tokenizer is working with pieces of text. So we have important concept token ID. Think of the tokenizer's vocabulary like a dictionary, where every token has an identification number. For example, just for illustration, hello might have ID, one ID, AI might have another ID, and the exclamation mark another ID. These numbers are called token IDs. So we have token to token ID. The actual number depends on the tokenizer. So now we can see the complete picture. You can start with human text. The tokenizer breaks into tokens, and those tokens are represented using token IDs. The model processes that information and generates new tokens, and those generated tokens are converted back into the text you see. So remember this flow: text, tokens, token IDs, LLM, generated tokens, and finally text. Now let's connect this to something more, much more practical: AI agents. Imagine you are building an AI customer support agent. The user asks a simple question, but the model may need much more information than just that question. It may have a system prompt telling it how to behave. It may have conversation history. It may have information using RAG. It may have access to tools. It may use memory, or it may communicate with MCP servers. All of this contributes to the context the model processes. Let's make this practical. Imagine our agent has 1500 tokens in its system instructions, 3000 tokens from the conversation, 7000 tokens from the retrieved documents, and another 1500 tokens from tool information, and the user's question is only 200 tokens. That's already around 13,200 tokens before we generate the response. So the model isn't processing only the user's question, it's processing the entire context. This also explains context windows. You may hear terms like 32K, 128K, or 200K context. These numbers refers to tokens, not words. So when someone says a model supports a 128K context window, think approximately 128,000 tokens. The number of words represented by those tokens can vary depending on the language and the type of content. The same idea applies to RAG. Imagine your user asks about company's leave policy. Your retrieval system finds 20 documents. Do you really need to send all 20 documents to the model? Probably not. You want the most relevant information, because unnecessarily information means unnecessarily tokens. So good RAG design is also about controlling the amount of information entering the model's context. Tools work the same way. Every tool can have name, description, parameters, and results. All of these contribute to the model's context. And when you add MCP and multiple tools, the context can grow even further. So don't only ask what tools can connect. Ask whether your agent actually needs all of them. And one more important point. You may hear people say that 4 characters are approximately 1 token. You can use that as a rough estimate for some English text. But it is not an exact formula. Different languages, code, numbers, URLs, and names can tokenize differently. So when you need an accurate number, use tokenizer for the specific model. And this is the mindset I want you to develop. When you see a prompt, don't just think about how many words it contains. Think about how many tokens it consumes. When you see conversation history, think about how many tokens you are carrying forward. When you see RAG, think about how much context you are injecting. And when you see tools or memories, think about how much additional information you are giving to the model. So let's quickly summarize. A token is a piece of text, not necessarily a complete word. BPE and similar approaches allow tokenizers to allow with reusable pieces of language. Each token has a token ID. The LLM processes tokenized information and generates new tokens. And when you are building AI agents, tokens appear everywhere in prompts, RAG, memory, tools, MCP, and conversation history. So don't just look at your AI application and think in terms of words. Start thinking in terms of tokens. Because when you understand tokens, concepts like context windows, prompt, optimization, RAG, memory, tool, design, MCP, and LLM cost optimization become much easier to understand. Humans read words. LLM processes tokens. And as an AI engineer, you need to understand if you're learning generative AI, LLMs, AI agents, and practical AI engineering. Follow me for more simple and practical information. Thanks for watching.